Hello everybody, I'd like to talk about our work and empirical study of C++ vulnerabilities and crowdsourced code examples. This work is done at Shiraz University with collaboration with Foots and EOS. Well, we focused on Stack Overflow and we wanted to see if the code snippets from Stack Overflow that are a coding platform for sharing knowledge actually contains vulnerabilities, and if these vulnerabilities actually go to a production and lead to vulnerable applications, even if they are accepted answers. So then also we focused on C++ because it's the fourth most popular language and is an embedded system language of 4, and the security problems can be high. In addition, for tagging the vulnerabilities, we use CWE because if we tag a vulnerability with, like here with CWE, we have description, scope, impact, and mitigation methodologies within the documentation of CWE. SOTorrent database is used because it contained 10 years of dumps of Stack Overflow, so we could go and see the evolutions of vulnerabilities and evolutions of code. Stack Overflow does two interesting things. First, in each post, based on some heuristic, it extracts codes from the text. In addition, based on some other heuristics, it finds how this code have migrated to other projects. So basically, we have code snippets in somewhere and references to other projects for each post within SOTorrent. We looked at various work on Stack Overflow, that the code is shared in various platforms from Python, Java, API. We also saw a lot of work on security of Stack Overflow in various languages like Java, Android, Python, but we didn't see any work on Stack Overflow on C++. In addition, we looked at GitHub vulnerabilities and vulnerabilities that people found in GitHub. Again, we didn't find work on C++ on GitHub. And more importantly, no migration from vulnerable C++ to GitHub. That was the main concern. So we took SOTorrent dataset, we extracted C++ codes, we removed the unwanted codes and make sure we checked the unique code, and we looked for vulnerabilities through various stages of assessment and manual review process. Among 41 million question and answers, only 500,000 questions are in C++. These are the number of answers, and with the history we have 1,700,000 answers. If you look at the distribution of C++ answers, you see this distribution, and these are the distribution of Stack Overflow code snippets in GitHub. We used the syntax net because actually the code snippets that were extracted, some of them were like this, they were not actual code snippets. And because it stores the history, the 1,700 answers in C++ with migrated to GitHub led to 121,000 codes. But when we checked 121,000 code snippets, possible code snippets, 72,000 of them were actually codes. Some of them like this were not codes. SyntaxNet provides a probability if it's a C++ or if it's not a C++. So we focused on those actually for 72,000, and we wanted to make sure they are unique. And the best clone detection for clone 1 for C++ and Java is SourceRCC. After we analyzed 72,000 code snippets, we found out over 2,000 are unique, so we started the manual review process. In the first review process, we just checked what might be having a vulnerability, and we ended up having 500 almost code snippet that may have vulnerable code snippets. Some of them that didn't have functionalities, or some of them that didn't have long lines, so were omitted. We read in those 500, we read the questions, we looked at the last version of the answer, the description, we read the comments, like all the comments of the post. In addition, we checked for dangerous and duplicated and depreciated function. We checked the arguments, and we checked the functions by the official documentations of the language to make sure if there are no vulnerabilities. The 3 graduate students actually used this web application that they developed for this, and they reached a consensus for each vulnerability. On the second round, they put a CW tag, they put reference, and they also presented an attack scenario, and they put official documentation for the description. Like for this one, they added like RAND is CW 477, or this one can lead by off1 error, and also improper check for upper bound. Or in this one, the return value for malloc is not actually checked, so it can lead to null pointer reference, and some other examples. So we ended up having 99 code snippets that are vulnerable in 69 vulnerable answers. Some of them were in the latest version, some of them were in the history. And these are the distribution of introduction of those vulnerabilities per year. And these are those vulnerabilities and their frequency per year based on CWAIT. So later on, we tried to see, in addition to the GitHub project, we used them heuristic, and based on our heuristic, we searched for specific patterns that we felt that might lead to an actual vulnerability. Based on GitHub references, those 69 vulnerable answers were present in more than 2,800 projects, GitHub projects. So although 69 is small, but 2,800 is a large number. And based on our heuristic, 287 of them had a very high possibility that they had the vulnerability. And these are the distribution of those vulnerabilities. We actually reviewed them. We checked them one by one, and we noticed among those 287, 253 had actually detected the vulnerability that is actually migrated. These are the fixed by boundaries. This one or this code snippets were fixed. We sent the developers description of the vulnerability, why, and we provide them examples how they can fix them through mitigation strategy, and they provided official reference so they understand why we claim that their code is vulnerable, and it's not just a subjective issue, it is objective. Based on our analysis, only 13% of the people, although we provided all the information, fixed their vulnerable code, and a lot of them, they didn't want to fix it, or they say they don't know, or they said it is not their problem. Based on the answers to their questions, they felt that it is needed to have an online and actually informative tool, so we created a plugin for all the browsers so it can explain. They provide mitigate scenario references and suggested another safe post in the Stack Overflow. And to check our heuristic, we also compared our chosen keyword with a random keyword, and we showed that it is statistically significant with compared to other forms. The work is published in TSE and some news agencies like Register and BBC. Moreover, MetaStack Exchange talked about it, and also the managers of Stack Overflow had a discussion with us. So basically, we found 69 vulnerable answers that migrated to 2,800 questions. We informed the GitHub users, and they didn't fix it. And we created a browser. All the package and replication and the code are available in the replication package. Thank you very much.
All right, hello everyone. Welcome to this session. My name is Jeff Carver. I'm from the University of Alabama in the United States, and I'm happy to have Ashkan here to answer questions about his presentation. I have a couple to get us started, but please, if you have questions for him, please put them in the chat so that we can that I can ask those. So let me start with the first question. Your paper was about results in C++, and do you have any thoughts on what is specific from your results that's relevant only to C++, or maybe how would anything that you found apply to other languages? Do you have any thoughts on that?
Well, actually, the reason we focused on C++ was because it has vulnerabilities, and also we wanted to make sure, and those vulnerabilities are not very difficult to detect, and we were just monitoring how C++ migrated to, vulnerabilities migrated to actual GitHub projects. But I believe the results can be replicated for other languages, and we invested some time on other languages also. But I think the main issue that we were trying to show was that you cannot just stick to the functionality. You have to learn from the hard way, and you have to learn secure coding. You just cannot copy and paste, and you end up with a vulnerable application. That was the main issue that we were trying to show. But I think all the other languages can have the same problem to some extent.
Okay, great. We have a question from Jasmine. It says, did you see a correlation between the security issues in the Stack Overflow answers and verified answers, or number of upvotes or badges from the user that posted it?
Actually, we focused on accepted answers. I mean, that was the frightening part of our analysis. We didn't just look at any answer that was put in the questions. People actually showed that those answers that had vulnerabilities and were migrated to other projects were accepted answers, and that's pretty scary because and the scariest part was even after we told the developers that, hey, we are not making subjective decisions, and we showed them links to official documentation that these vulnerabilities are actual vulnerabilities. They didn't fix them much. I mean, we contacted a lot of developers. We told them about the vulnerabilities in their applications. We even gave them the mitigation strategies, but nobody actually, not so many actually fixed them. So I think that's pretty much an alarming issue.
So I had another question that's kind of a follow-up to that one. Why do you think, or do you have any sense of maybe why, when you did this survey back to the respondents, why did they disagree with your analysis? Seemed like some of them said that they didn't agree that there was a problem. Do you have any idea why they might have disagreed?
Exactly. Well, I think it's, in a sense, the reactive notion that people have towards security. I mean, all the developers, in a sense, they love what they produced. It's like their child, and it's hard for them. So somebody comes and tells them, okay, what goes to production, what is actually a deployed application, you did this and that wrong. And another problem is, so we basically teach about software security too late. I mean, we first teach students how to program, and after they learn how to program, then in graduate school or in upper undergrad school, we start teaching them about software security. They learn how to code, and that's, in a sense, a defensive attitude they get toward when they hear about security issues. I think, I mean, what I tried to convey the most was people need to learn the hard way, and they have to learn about security issues in their coding. And we wanted to also raise an alarm, so Stack Overflow people also become concerned that they should put like a security tag or something in addition, just to check the functionality of the code.
Okay, great. Another question is, did you have a chance to analyze the overall code from the users that took the answers and integrated them? So the ones that, I guess she's asking the ones that actually changed their code. Were there any major quality issues that you saw?
Well, if I understood the question right, we found like 99 problematic answers that they had vulnerability problems after a very rigorous and restrictive code. Okay, and but what we actually did, we used some heuristics just to make sure if the vulnerability is actually still exist in the application. Okay, and we just, as I said, we just focused, and we manually checked. We manually checked if the vulnerability has been fixed or has not been fixed in the 2,800 projects that we checked. But other issues or other major quality issues, we did not pay attention, and that could be a nice question to follow.
Great. So I have one more question. If anybody else has other questions, we still have a few more minutes left. Is your approach at all automated? It seemed like when I was watching your presentation that there was a lot of manual effort to get the results. So I'm just trying to think about how this might work for other projects that weren't already in your initial set of analysis. So is it very manual? Is it automated? Kind of how can this be used by maybe other projects going forward?
Well, to be honest, that was the main obstacle, that we couldn't extend the study to so many languages in a very short time. We actually manually assessed the 2,500 code snippets that we ended up, and after students looked at the code, they would bring it back to me. I would check them. And as I said, we were very restrictive to make sure that the vulnerabilities that students are introducing or say this code snippet is actually a vulnerable code snippet. The problem with the regular static checkers is they can check like for depreciated code or obsolete operators, but you cannot take a small segment of a code and at the same time you run a static checker and tells you if all the vulnerabilities are there. I mean, usually for real vulnerability assessment, you need the whole code to make sure if the vulnerabilities are actually there. But because we were dealing with code snippets, the way we reached was, I mean, it had a lot of tedious and manual work in it. Definitely automating the process would help a lot and can give insights to managers so they can tag some of the posts so people use them with care, or they do some mitigation before production.
So do you see any potential for automating any of that process to make it more easy to use for others in the future?
Well, yeah, I mean, what we actually should do, and we should try to do, is to process more codes. And as I said, in our study, we were not focused to find all the vulnerabilities. We wanted hard evidence that when we show people, they can say, okay, this is it. I mean, there's no, how can I say, nobody can question our results, to be honest. But definitely, as you know, static checkers give a lot of false positives, and then they need manual reviews. But I think that kind of thing is also useful. So it gives at least the post some flag, and definitely I think automating with other.
All right, sorry to cut you off. We have just about 2 seconds. The next video is going to start. Please go to the description.